Hello, I am the Understudy, and this is the channel where we discuss everything musical theater related. Today, we are reading Barron's AP Music Theory, 3rd edition, by Nancy Fuller-Skoggen, BME. This is a long and extensive book, and I'm working my way through it to learn more. These videos are a way for me to organize my journey, but I am very happy that you're here with me. Before we start, if you have any questions throughout these videos, type them in the comments, and I'll see what I can do to clarify anything or maybe make a new video. This is part 2, Rhythm, Meter, and Metric Organization. Let's go. First, the vocabulary, we have a la breve, anacrusis, bar line, beat, beat type, including compound and simple, changing meter or multimeter, common time, dot or a double dot, dotted rhythm, duplet, triplet, duration, downbeat, hemiola, regular meter, meters as asymmetrical meter, duple, triple, quadruple, note value, rhythm, subdivision, syncopation, tempo, tie, and time signature or meter signature. Notating rhythm. Music is sound and silence in time. Throughout the history of Western music, composers have represented sounds with symbols called notation. It is our written musical language. Music notation does not indicate the exact duration of sound. Instead, it shows how long one note lasts in relation to another. It is a common mistake to simply say the whole note gets 4 beats, or a quarter note gets the 1 beat. It does sometimes, but not always. What is always true is that 2 half notes equal 1 whole note, and 2 quarter notes equal the duration of a half note. The following illustration shows the relationship of durational symbols, usually called the note tree. Here we have a double note, or breve. We have 2 whole notes. We have 4 half notes. Then we have the quarter note, 8th notes, 16th notes, 32nd notes. And all of these, you can see a slight square here, box, is equivalent to 1 quarter note. This illustration shows the relationship of the equivalent rests, the rest tree. We have the double whole rest, very rarely used, but still exists. We have the whole rests leaning on top of the second line here from the top. We have the half rest leaning on the middle line, on the top of the middle line, so leaning on the bottom of the space. Then we have the quarter rest, the 8th rest, the 16th rests, and the 32nd rests. And all of these, 4 of these, 2 of these, 8 of these, are equivalent to 1 quarter note or 1 quarter rest. The dot and the tie. The dot and the tie are 2 symbols that extend the length or duration of a note. They both serve the same purpose, to make durations longer, but visually look much different. The dot is used to extend the value of a single note by 1/2 of its original value. In the half note, if the half note receives 2 beats, for example, the dotted half note has the value of 3 beats. If the value of a half note is 1 beat, then the dotted note receives 1.5 beats. The quarter note divides equally into 2 8th notes. A dotted quarter note divides into 3 8th notes. A second dot, a double dot, lengthens the dotted note value by the half length of the first dot. The dot and the double dot apply to rests as well as to notes. If the half notes and the half rest receive 2 beats, then the dotted half note or rests has a value of 3 beats, and then doubly dotted half note or rest equals 3.5 beats. While the dot increases the value of a single note or rest, the tie combines the durational values of 2 or more notes of the same pitch using a curved line. Ties allow us to extend the duration of a pitch beyond a single measure. Just to clarify this image here, this dot that we see here means that we take the full value of the notes and then add half of the value. So we see these quite often in music, and it simply means that the note is extended half its value. When we see the double dots here, it means that we have the full value plus half of the value plus half of this value. So it's the dot of a dot as well. Not as commonly used, but you can see it in music everywhere. And it can also happen to arrests, even though that's even less common. Okay. Metric organization. In its widest sense, rhythm is the flow of music through time. Rhythm is basic to life, and it's the lifeblood of music too. Rhythm and meter are often misunderstood and can frequently be an area of confusion. Let's begin by defining basic terminology. Duration, the length of time sound or silence occurs. Beat, a regular, recurring pulsation that divides music into units of time. Meter, the organization of beats into regular groups of 2, 3, and 4, usually with strong beats and weak beats, and how the beat is subdivided. Subdivision, the division of the beat into 2 or 3 equal parts. Rhythm, series of durations, often varying, of sound and silence. Tempo, the speed of the beat. Meter is the organization of musical time into recurring patterns of strong and weak beats. Each complete pattern is a measure. The patterns group into duple, meaning 2 beats per measure, which is a strong, weak. So 1, 2, 1, 2, 1, 2. We have triple, which is 3 beats per measure, which is strong, weak, weak, strong, weak, weak. Then we have quadruple, which is 4 beats per measure, strong, weak, less strong, weak, strong, weak, less strong, weak. Additionally, the number of subdivisions per beat provides more information about the meter. The meter signature, or time signature, at the beginning of a musical score establishes the grouping of the beats and the nature of the subdivision of the beat. We have simple meter and compound meter. Simple meter refers to the beat being divided equally in 2 parts. See, all of these are divided into 2. Whole gets 2 halves, half, 2 quarters, quarters, 2 eighths, and eighths, 2 sixteenths. The compound meter refers to a beat being divided equally into 3 parts. So compound meter normally has a dotted note as the beat. We have a dotted half, which divides into 3 quarters. We have a dotted quarter, which divides into 3 eighths, and a dotted eighth, which divides into 3 sixteenths. Here's an if-then chart to help determine the meter. The numbers in this chart help to refer to the top number of the time signature. So, here we have the duple, triple, and quadruple. We also have simple and compound. Okay? Let me see. Okay. If the top number is a 2 or a 6, then you have a duple meter. If the top number is a 3 or a 9, then you have a triple meter. If the top number is a 4 or a 12, then you have a quadruple meter. If the top number is 2, 3, or 4, you have a simple meter. If the top number is 6, 9, or 12, then you have a compound meter. Okay. Simple meter. What you see is what you get. Represents a time signature in simple meter. The top number represents the number of beats per measure, and the bottom number represents the fractional equivalent of that note in the beat. There will never be a time signature with a 7 on the bottom or a 10 on the bottom, because there's no such thing as a 7th note or a 10th note. Hold on, I'm gonna... Excuse me. Okay. So, a time signature of 216, 28, 24, or 22 is called simple duple. So here we have 2, and all of these are simple meters. So simple, duple. A time signature of 316, 38, 34, or 32 is called simple triple. This is because this is 3, and all of these are simple. Here's also the note that gets measured, the beat. So 2, half, 4, quarter, 8, eighths, 16, sixteenths. And here we have a time signature of 416, 48, 44, or 42 is called simple quadruple. And the beat note is half, quarter, eighths, sixteenths. Sometimes 3/8 or 3/4 is at very fast tempo, treats each measure as a single compound beat. But this is not really used in the AP exam yet, but it's something that happens so that you get 1, 2, 3, 1, 2, 3, 1, 2, 3, if it's very fast. Okay. You may also see other time signatures that represent simple meter. For example, a C is called common time and is frequently used to represent 4/4. It's just a C. It's a cursive C, but we also have cut time or à la brève, which is substitute for 2/2, and it's a C with a line straight through it. Okay. Compound meter. If in compound meter, the beat is normally a dotted note, there is no fraction that represents a dotted note quarter or a dotted half note quarter. Oh wait, sorry. If in compound meter the beat is normally a dotted note, there is no fraction that represents a dotted quarter or a dotted half note. Therefore, in compound meter, the time signature represents the subdivision and not the beat. For example, 9/4 time signature represents triple compound meter. There are 9 quarter notes, or the durational equivalent, per measure. The beat note is the dotted half note. This. But there are 9 quarters. You would conduct in 3. Each dotted half note receives 1 beat, and the beat is divided equally into 3 parts, quarter notes. We have a time signature of 6/16, 6/8, commonly used a lot of the time, 6/4 and 6/2, which is compound duple. And the beat note is a dotted whole, a dotted half, a dotted quarter, and a dotted eighth. Sorry. Then we have time signature of 9/16, 9/8, also commonly used, 9/4, and 9/2, which is compound triple. The beat note value, or the beat note, dotted half, a dotted whole, a dotted half, a dotted quarter, and a dotted 16th. A time signature of 12/16, 12/8, 12/4, and 12/2 is compound quadruple. This beat note is a dotted whole, a dotted half, a dotted quarter, and a dotted 16th. And you can see if we would divide these into 3, then we would get here at the top, we would get a 2, just like in simple duple. And if we would divide this into 3, we would get a 3, just like in simple triple. And here we would get a 4, just like in simple quadruple. Okay? Let us continue to some asymmetrical meters. The term asymmetrical means not symmetrical or not equal, and refers to meters that have beat units of unequal length. The most common asymmetrical meters have 5 or 7 as the top number. An asymmetrical meter such as 7/8 could mean 2 plus 3 plus 2, which might make the beat units within one measure a quarter note, a dotted quarter, and a quarter note. Or 3 plus 4, or 3 plus 2 plus 2, would be dotted quarter note, would be quarter note, dotted quarter, dotted quarter. I'm sorry, no, this is wrong. 3 plus 2 plus 2 would be dotted quarter, quarter notes, quarter notes. How do you know which is which? When listening to music, beaming of the notes clarifies the beat and informs the eye. Correct notation reinforces the beat unit. Sometimes when the same division groupings occur for several forces of beat unit, sometimes when the same division groupings occur for several measures, the composer will indicate such in the meter signature, just like we have here. In the following example, the time signature would be 7/8. Triplets and duplets. In simple meter, the regular division of a note value is always the 2 equal parts. An irregular division occurs when it is divided into an odd number of parts, 3, 5, or 7. This type of division requires a bracket and a number, or simply the number, if the notes are beamed. Okay, so simply the number, like we see here. We don't need the bracket as well if the notes are beamed. The most common division is the triplet, dividing a regular duration into 3. This happens all the time in simple meter. This can also be explained as borrowing the beat unit from compound meter by imposing a triplet into a simple meter. Likewise, in compound meter, as we see in the bottom here, the beat is normally a dotted note and divides into three equal parts. Therefore, a simple division of a dotted note occurs when two notes divide the beat instead of three. This type of division also requires a bracket and the two and is called a duplet or a tuplet. This can also be explained as borrowing the beat unit from simple meter by imposing duplets into compound meter. Okay. Downbeats and upbeats. Let's watch this one while we talk. The downbeat is what we commonly call the first beat of the measure. This label refers to the fact that in every conducting pattern, the first beat is always down. Not all music begins on the downbeat. Some songs begin on the beat that precedes the first beat. This is called the anacrusis, or pickup notes. You can see one example right here. In music that begins with an anacrusis, the last measure is incomplete so as to balance metrically with the pickup notes, the anacrusis, and the last measure will equal one complete measure. So here we see this is the example for common time, the C that I talked about earlier. And here we have 1, 2, 3, and 4. Melodically, an anacrusis is very often so leading to do on the downbeat. This is a following example of Air in F major by Bach. Notice how the melody begins on beat 4 and is so do in the key of F major. The last measure of this excerpt has only 3 beats and repeats back to the beginning where the anacrusis is beat 4. I also would like to say that you see this symbol here, which means repeat. We'll talk more about that later. Wait, we actually have already, sorry, in the last chapter. Sometimes they put a similar here and they extend this beat all the way so that this has the full 4 beats and that there is no use to replay this. So you would just play this and then the end would start here. That's another way to play it. Okay, we also have syncopation, is the rhythmic displacement of the expected strong beat created by dots, rests, ties, accent marks, and dynamics. Syncopation also occurs when the emphasis or stress is between the beats or on a normally weak beat. Because syncopation emphasizes a beat or a part of a beat other than the one expected, it creates a conflict in the established grouping of beats. It is an interruption of the regular flow of rhythm. It can also be placed of stress, accents, or even longer durations where they would not normally occur. Here is an example of syncopation. This is a style of music called ragtime, popular during the turn of the 20th century that features syncopation. This example uses the tie, as you see here and here and here, to add length and therefore stress on the upbeat. It also uses syncopated rhythm to create stress in between the beats. Okay. A hemiola or hemiolia was used in the common practice period as a special style type of syncopation in triple meters, in which the beat is temporarily regrouped into twos, and as is in this example from Piano Sonata by Franz Schubert. Wait, this is actually not the same example. Well, it is, but it doesn't have all of the text up here. Anyways, so here we have 1, 2, 3. Notice the upper staff of the rhythm is temporarily grouped into units of 2 because the half note rhythm uses the tie across the bar line here, even though the time signature is 3/4. So we have 1, 2, 3. Yeah. A more modern application of hemiola, sometimes called a cross rhythm, is a metric device where the rhythmic relation of 3 notes occurs in the time of 2. It consists of superimposing 2 notes in the time of 3, duplet, or in 3 in the time of 2. So basically doing it more manually. Okay, rhythmic notation guidelines. When writing music, the stem can be attached to the note head on the right side, extending upward, or the left side extending downward. For pitches on the middle line and above the staff, the stem go downward. For pitches below the middle line, the stem extends upward. When drawing notes with single flags, the stag goes on the right side of the note regardless of whether the stem is up or down. Rhythmic patterns should be grouped on the beam to indicate beat units. When a beaming pairs or multiple of notes, you will determine the stem direction by the note that is farthest from the middle line. The ability to notate rhythms correctly will also improve your ability to sight sync rhythms quickly and accurately. Let's do some review. This is very early music, written in the 16th century, and has four staves for four vocal parts connected into one system. The two top staves are for the female voices, as we can see in the clef, and the bottom two staves are for the male voices. We have a treble clef that is an octave down, and we have the bass clef. The third staff is designated as the tenor part with the treble clef and the number 8 below indicating that the tenor will sing an octave lower than is written. It is written this way to avoid using ledger lines. If the tenor part was written in bass clef, it would look like this, as we see here at the top. So this is what it looks like here, and here we have a bunch of ledger lines. The time signature is, let's go back, 2-1, which is simple duple meter. There are 2 beats per measure, and the whole note gets 1 beat. One measure in this time signature contains 2 whole notes, or the equivalent of 2 whole notes. So here we have a 2, and here we have a 1, meaning 2 of these. We can see that it all equally maths up to that. The second measure is an interesting one rhythmically. This one. Let's look again at the tenor's line. Look at this one. The second measure is syncopated because the emphasis is in between the beats. This upsets the normal duple meter and makes it asymmetrical in this measure. The bass line, however, this one, continues with straight 2 beats per measure, subdivided into 2 parts. Because of the way these are notated, the beat units of these measures look like the example on the next page. So on this one, this is what it looks like. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 1, 2, 1, 2, 3, 4, 1, 2, 3, 4. Okay? Cool. Some chapter summary. Rhythmic notation does not indicate the exact duration of sound. Instead, it shows how long one note lasts in relation to others. Music is metrically defined by the groupings or organization of the beat into duple, 2 beats per measure, triple, 3 beats per measure, or quadruple, 4 beats per measure. The number of subdivisions per beat provides more information about the meter. Simple meter refers to the beat being divided equally into 2 parts. Simple meter signatures are most likely to encounter are simple duple, meaning 2-8, 2-4, and 2-2. Simple triple, meaning 3-16, 3-8, 3-4, 3-2. Simple quadruple, 4-16, 4-8, 4-4, and 4-2. The most common ones of these are 3-4 and 4-4. Compound meter refers to the beat being divided equally into 3 parts. Compound meter always has a dotted note as the beat. When the time signature is simple meter, the top number represents the number of beats per measure and the bottom number represents the fractional equivalent of the note that is the beat. In compound meter, time signatures represent division of the beat and not the beat. So compound meters that you are most likely to encounter are compound duple, meaning 6-16, 6-8, and 6-4. Compound triple, meaning 9-16, 9-8, and 9-4. And compound quadruple, meaning 12-16, 12-8, and 12-4. And the most common ones of these, of course, is 6-8, very common. Also 9-8, 12-8, and sometimes even 6-4. Not all music begins on the downbeat. Some songs begin with an upbeat that precedes the first beat. This is called an anacrusis or pickup. In music that begins with an anacrusis, the last measure is incomplete as to balance metrically with the pickup. Syncopation is the rhythmic displacement of the expected strong beat by using dots, rests, ties, accent marks, and dynamics that create a conflict with the established grouping of beats. Hemiola was often used in common practice period as a special type of syncopation in triple meter. in which the beat is temporarily regrouped into twos instead of threes. And that is the end of part 2, rhythmic meter and metric organization. So thank you for watching. If you have any questions, make sure to type them below and I will answer them or make a new video or whatever. I know can be a lot of information. And I would like to make my own little guide of it, not just following this book. But yeah, if you like what you see, I'd be honored if you sorry, that's loud. If you like what you see, I'd be honored if you subscribed. And if not, go hop over to the quiz or watch the next video. Thank you.